Okay, so problem number 9. Values of the terms of the geometric sequence g sub n are graphed in the figure. Which of the following is an expression for the nth term of the geometric sequence? Okay, so there are, like we said with problem number 1 and 3, that there are just an infinite number of ways to write the sequence depending on what number you're starting from. So let's see what number each of these are starting from. So this one starts at the second term. So our k is equal to 2. So it starts at the second term, and it says the second term should be 4. So 2, 4 should be on our graph. 2, 4. So this one checks out. Let's try this one. This one says the first term of our sequence should be 8. So if this was true, 1, 8 would be on our graph. 1, 8 is on our graph, so that one's okay. Then let's see here. This one says that 0 and 8 should be on the graph. Well, 0, this should be a 16, so this one is not right. And then this one says the first term is 16. Well, that's not true. The first term is 8, so it can't be that one. So we've narrowed it down to A or B. So now let's look at the ratio. This ratio is 1/2. This ratio is 2. Looking at this is decreasing by half, so it can't be the 2. It must be A. There we go, because our ratio is 1/2. Okay, number 10. The fifth term of a geometric sequence is 24, and the sixth term is 28. What is the value of the 10th term? So this looks like it is, so we have 5, So the fifth term is 24, and the sixth term is 48. So we can write our sequence here. This is geometric, so we need to have a common ratio. And our common ratio, since these are right next to each other, so we can just do 48 divided by 24, which is 2, which is our common ratio. So we can write this as g sub n is equal to 5 times our ratio, which is 2, to the x, or the n, to the n, and since this should be 5, this should be 24, my bad. Our y value is 24. And since we use the fifth term of the sequence, then this should be n minus 5. And we want to find the 10th term, so g sub 10 is 24 times 2 to the 10 minus 5. And we can plug that into our calculator. 24 times 2 to the 10 minus 5, which is 768. So g sub 10 is 768. Okay, number 11. The general term of a sequence is given by this function here, where a sub 0 is the initial value. Which of the following expressions also gives the general term of the sequence? So again, there's an infinite number of ways to write this. It all just depends on which number you're starting on. It looks like this one is starting on the 10th element in the sequence, and the 10th element is 51. So 1051 is on our graph. So we can actually figure out, we can simplify this a little bit. We can just distribute the 3. And so I get 51 plus 3n minus 30. Collect our like terms, and we get 3n plus 21. 51 minus 30 is 21. And we can look over here and see that, 3n and 21, it's going to be C. Number 12, the temperature of a hot object cooling can be modeled with the function h, and time is measured in minutes since the object started cooling. H of t is measured in degrees Celsius, and the function h has an exponential decay function. So let's see here. So it's exponential decay, so we're going to have some exponential decay function here. And we know that this object, the temperature decreases 10 degrees over 4 to 7 minutes. So from here, we'll say that's 4. We'll say this is 7. And it decreased 10 in just 3 minutes. Its average rate of change. Now for it to decrease another 10, let's see if I can't make these roughly the same size. And it says afterwards, after 7 minutes, it decreases another 10 degrees. So which of the following statements about, so that's another 10 degrees down. And so which one of the following statements is true about the time the object required to cool that additional temp? So we're looking at this time right here. How long did it take to cool another 10 degrees? So that's what we don't know. The object required more than 3 minutes to cool. So when I look at these, if it has a long, I check claim by claim. So this one says the object will require more than 3 minutes. Well, we can see this is concave down, and so it's decreasing in concave down. So we're looking like this. This line right here is longer than that line right there. So it should take longer. So more than 3 minutes is good, more than 3 minutes. Fewer than 3 minutes is bad, and fewer than 3 minutes is bad. It's going to take longer for the second 10 degrees to happen. So then the next section says, why? So it's asking, why does it happen? So is it because as t increases, so as time goes on, the rates of change are negative and increasing? So here's where you got to kind of not get caught. They're talking about the rates of change of h, not h itself. So let's look at the rates of change of x. So of h. So h is decreasing. So h is decreasing, which means that the rate of change is negative. Because the function is decreasing, the rate of change is negative. And we know that h is concave up, which tells us the rate of change is increasing. Okay, so this says the rates of change are negative. Check, yep. And increasing, check. So this one seems to have everything. Let's see what this one says. The rates of change are negative, check, and decrease. No, well, this says decreasing, so that one should be wrong. So it should be A. Should be A. Okay, that concludes the second page. Let's go to the third one in the next video.